Now welcome to the next session in data types in basic operations. This session will have the following objectives. We will see about subsetting in list as well as matrices. We will see about partial matching, vectorized operations, and removing NA values in detail. We saw that about removing NA values in the previous session, but we will see in more detail in this session. Subsetting. What exactly is subsetting? You have a set of data which contains a list of values, for example 1 2 3 4 5. Now you want to extract only values which are greater than 3. So from 1 2 3 4 5 you are extracting only 4 5. So extracting this 4 and 5 from the set of 1 2 3 4 5 is called subsetting. You actually created a subset which contains values 4 5 from a set of 5 individual elements. So here R provides a list of operators that can be used for extracting subsets. For example, the single square bracket, which it can be used to extract a same class of object from the previous one. It can be used to select more than one element, and the next set is double square brackets, which can be used to extract elements of a list or a data frame, which will normally contain it is similar to an array within an array in C program. It can be used to extract a single element and the class of the return object not necessarily be the list or a data frame. Now we can use dollar to extract elements of a list or a data frame by name. Semantics are similar to that of double square brackets. Now we'll see subsetting examples. Now let's say there is a set of values. We'll replicate this in the console. Let's say we have a set of values inside a vector R, vector X. It contains 6 values A, B, C, D, D and A. Now when you print this, you will get all this A, B, C, D, D, A. Now I want to extract only values B, C, D, D, which means which are greater than A. That's right. You can also use operations on characters as well. Now I want to create a subset where we have values greater than, I've used a single set of brackets which will display only B, C, D, D, which will exclude A and A. Now I want to create a logical vector which will contain only the operators, only the values of resulting operation. X greater than A is nothing but a operator which will return either true or false. If A is greater than A, it will return true, but it is not, so it will return false. And same way for B, same way for C, same way for D and others. Now this U will contain only Boolean values, false which indicates A is not greater than A, and true indicates all these values are greater than D. Now you can use these, the value U inside X, to extract specifically BCDD, which corresponds to true. Now I say if I extract X of U, it will give me only BCDD, which will remove these A values. Now let's move on to the next one, subsetting a matrix. The same way we are subsetting a list, the same way we are subsetting a vector, we can subset a matrix as well. For example, let's say there is a 1 cross 6 matrix. Let's say there is a matrix which contains the elements 1 to 6 and the number of rows is 2 and the number of columns is 3. Now we have a matrix like this. Now we want to extract single elements from this. Let's say if you want to extract the value 5, the dimensions corresponding to 5 is 1, 3. Now if you use this 1, 3, we'll be able to extract the value 5. This is what subsetting actually is. Now if I want to extract the entire row 2, I can do X of 2, which means the row 2 and the column name is not specified, which will indicate R to extract only the second row. Now 2, 4, 6 alone is extracted. Moving on to the next part, subsetting a matrix. When a single element of a matrix is retrieved, it is returned as a vector of length 1 rather than a 1 cross 1 matrix. When a matrix you are creating a subset, the subset is not a matrix. That's what I'm trying to imply here. This can be turned off by using a setting called drop, and if this drop setting is uh, mapped as false, the value returned will be a matrix as well. For example, in the same example that we saw earlier, we extracted x of 1 comma 3, which is 5. Now let's say I want to extract the same. This x of 1 comma 3 is returning the value 5, and this is a vector of length 1 rather than a matrix itself. So let's say I want to extract x of 1 comma 3, but now I want this as a matrix. Now if I set this as false, the resulting, pardon me for the mistake, I used a set bracket. So if I use false, the resulting set subset will also be a matrix. Now moving on, a single column or a single row will also give me a vector when you are subsetting it, and it is not a matrix. Same thing, we'll go with the same example of extracting x of 2 comma and extracting the second row. Let's say I want to extract the second row, but this time I want it as a matrix. Now this will give me a matrix 1 cross 3 matrix which contains the values 2, 4 and 6. Now moving on to subsetting of lists. Let's say we have a list which contains two elements. List of, let's say, A equal to 1 to 4. It's a sequence of 1 to 4, comma B is a numerical value. I've created a list. Now in this list, if I want to extract only the first element, x of 1, it will give me $A, which will give you the sequence of 1, 2, 3, 4. The first element is nothing but an integer sequence, and the next element is a numeric value. As you can see here, using the double brackets, you can exactly do the same thing again and again. So let's say I want to extract the first element. Within the list of x, I can extract 1, 2, 3, 4. And the same way you can use x $A, which will give you the first element. Same way you can use x $B, which will give you the second element. The same way you can use the double brackets also to extract either using the name A or the first element. It also give you the same value. So there are multiple ways to extract subsets from a set. Now how can we extract multiple elements of a list? Let's say I want to extract 2 of 3 elements in a list. For example, let's say there is a list which has elements A, which is a integer sequence, element B, which is a numeric value, comma C, which is a character sequence. Now this is the list. Now I want to extract only A and C from this list. How can I do that? If I use 1 comma 3 in the single bracket, I can extract this. The incorrect number of dimensions as I have entered is as a number of dimensions in X. Now to extract elements 1 and 3, I have to create a vector which contains 1 comma 3 and then extract those values alone, which will give me elements A and C. Now moving on to the next part, the single operator can be used with computed entities. These are like double square bracket operator. Dollar can only be used with literal names. For example, in this string, either it is $A or $C. This is the way we can use the dollar symbol, which can be used with names of the elements. But here you can use with computed indices also. For example, let's say we create a name equal to A. Now I want to use this name to extract only the element A from the list X. I can do that. Now I use name to extract the first element 1, 2, 3, 4 from the vector X. The same way we can use $A like I said earlier, but if I use $name, this will return null as this is a predefined character vector. It's a predefined character vector. Now moving on, let's see the subsetting nested elements of a list. Let's say the double square bracket always can take an integer sequence also. Let's say we create a list which has a 1, 2, 3